Swayam Prabha. Digital India. Educated India.
Hello all, welcome back to our course on digital accessibility, and in the previous session we spoke about emerging input technologies and what are the limitations of the traditionally known input technologies, and in this session we will talk about emerging output technologies and what are the limitations of current or traditionally known output technologies. And of course, in this session also there will be some discussion regarding use of AI and how AI's role is going to impact development of emerging technologies, because that is largely impacting most of the interaction devices, both input and output. So let us dive into it. So I am sure you are aware of the commonly known output devices. So output devices are meant to give you perceptible information, and you basically utilize that information. You are able to perceive the information projected by a certain output device using one or many of your modalities or senses, as we call it. Right. So monitor, I'm sure, which is like a screen, is something which is commonly known. Printer can be one which is able to produce like a hard copy print version of digital media. Speaker can produce audio. Headphones also produce audio. Then projector is also a good media. It is also able to kind of project it for a mass audience, while the screen or a printed version may be limited to single person use. So before we dive into the limitations of the output devices and the input devices as well, this is a video link which I will not play here because it contains sensitive visuals. You can watch it at your own convenience, and this is a story of Jared, who is suffering with cerebral palsy, and he is still a UX designer, visual designer. And what are the various input and output devices, how he interacts with computer in his day-to-day life is something which is very inspiring and also very informational to watch. Please watch this video at your own convenience. So let us now talk about the limitations of traditionally known output devices. So they do present significant accessibility limitations because they often rely on a single sensory modality output, right? So for example, a screen is only catering to the visual senses, right, which is like a screen. There may be some plugins etc. available which may enhance the usage, or assistive technologies available which may make the screen accessible, say for a person who is visually impaired, but for example a screen reader, but the technology itself is not multimodal. Technology itself is single sensory modality oriented. Same is the case with any speaker output, which is like a headphone or a speaker. These limitations surely create barriers for individuals with sensory limitations or cognitive impairments. And here in essence, like traditional technologies are often designed for an average user, which is where I think we've talked about this aspect a couple of times in the course, or rather abled user, which is what we call ability bias. And for that you can go back to week 1 or 2, where details about ability bias is discussed. And these biases have resulted in the currently used technologies, assuming that something which is visually communicating an information is catering to large number of audiences, while slowly people are realizing that multimodality is the way to go. And how in the similar manner, how input devices were catering to the operability aspect of the POUR accessibility principles, what do you think output devices are catering? Can you think about it? Yes, it is perceivability aspects of the POUR principles come under the output devices. So even in the perceivability principle, we always talk about multimodal ways of presenting information or communicating information to your potential user can make the information perceivable to them in multiple formats, and they can choose according to their sensory abilities. So most of the time these traditional technologies are designed for the abled user, and they fail to be perceivable enough to be interpreted reliably by a wider range of users, and assistive technologies etc. or plugins are required to make them accessible. So this is an example of such a technology, which is called enlarging screens. So here there is a book, and it's like a magnifying glass basically, and it shows the text in a very big format. So it is primarily for low vision readers, requiring ongoing manual effort. They may be expensive to retrofit, and even to achieve minimal accessibility standards, it may be very difficult with the traditionally known technologies. So let us talk a little bit more about what are the issues with the state of the art currently known output tech from different perspectives. So from a visual impairment perspective, there can be lack of alternative text or alt text, which kind of makes it unavailable for even screen reader users to understand what the image is about. So traditional visual displays or screens, static images etc. do not inherently provide text descriptions for non-text content. Non-text content means videos or images, making them inaccessible for users relying on screen readers or even braille displays for that matter. Color dependency may be one of the aspects, that information conveyed solely through color without any labeling is also inaccessible for individuals not only with blindness but also with color blindness. Poor contrast or text sizing, so fixed font sizes, or where they are not the users do not have the liberty to enlarge the size or minimize the size, or inadequate color contrast ratios, or lack of text sizing, resizing options make the text difficult or impossible to read for people with low vision or color blindness, or light perception. Light perception is also a condition which comes under visual impairment. That also, where the contrasts can be changed in order to make the text a little bit more visible. So these aspects have been comprehensively covered under the WCAG because they primarily come under screen based output, right. So all of these aspects, you can again go back to our session on WCAG. There are multiple sessions on WCAG guidelines. There are several sessions on the visual design aspect of accessibility. You can go back to those sessions to learn a little bit more. Here we are talking about output technologies and their limitations from the perspective of different kinds of users and different kinds of needs. In case of auditory impairments, so audio only content, so traditional audio outputs, say for example phone systems or public address information systems or announcement systems, are only loudspeaker based. Videos many a times don't have captions. So these kind of content or media excludes deaf or hard of hearing individuals, as there are no transcripts or captions alternatives provided by default. Volume control is also something which is very important, particularly if the videos or audios are embedded in a website or in an application. There is not a lot of interface available to increase or decrease the volume. If the app or the website enables usage of volume control through the device itself, then maybe some possibility, but the code itself has to allow that. And other than that, there should be muting mechanisms for that particular content, embedded content also. In terms of motor or mobility impairments, so reliance on mouse input, so literally traditional technologies are reliant on mouse based inputs, and output interfaces require a mouse for interaction. For example, a screen based interface, which is an output device, necessitates the use of mouse or touch screen based interaction, where it is again like a cursor which is moving in the space and is free to touch or free to click any part. But then even interaction with a mouse kind of an interface is an issue, and we have had a discussion about the same in the previous lecture, where we spoke about traditional and emerging input technologies. You can go back and check that session as well. So, which is a limitation for users who navigate only using a keyboard. Touchscreen sensitivity. So, the physical design, the technical specification of some touch screens may be too sensitive or very unresponsive for individuals with limited fine motor control or involuntary movements like tremors, etc. If it is too sensitive and the person has a tendency to have tremors, there may be multiple clicks which are unintended, while or on the other hand, if the screen is too unresponsive, people are trying to press the button but it is not pressing. So, the physical design and the physical sensitivity specifications of the device is also something that needs to be carefully looked at when looking at motor related impairments accessibility. Then we come to cognitive and learning impairments. So, complex interfaces, like interfaces that are visually cluttered, lack consistent navigation, or use complex languages or forms, and that can be challenging for individuals with learning or cognitive disabilities. Time sensitive information, for example, something, a password needs to be entered in a certain given amount of time, or OTP needs to be fetched from somewhere else and then entered in a certain given time. So that all of those activities, I'm sure you are now able to enjoy auto detect of OTPs and autofill of OTPs, all of those aspects. But yes, earlier it was not the case, and then all of these kinds of innovations in the digital accessibility space are not only making the interfaces more accessible for people with cognitive limitations, but also for everyone. So again, we come back to this same image, the same image we saw in our emerging input technologies talk. Because this is the kind of interaction we look at on an everyday basis, let us now kind of analyze this interface from an output technology perspective. From an output technology perspective, it has a screen, it has some speakers, audio, it may have vibration, vibrotactile, right? And because it's handheld, it can use that as well. It can emit light in cases when the phone is silent, etc. So the screen interface, there is a lot of guidelines around it, but these are basics which need to be thought about. Even for the clickability, the navigation, the perceivability, all of those aspects. Then audio has to be semantically intertwined with the video. Screen reader compliance, talkback, vibrations which are not random, which are also semantically associated. So semantics play a very important role in multimodal input and output interaction. So since there can be multiple output venues, audio as well as video, as well as a vibration, it should all be in sync with each other and should have some meaningful semantic association. So let us talk about a simple example. So I'm sure all of you might have used a wallet or for a UPI payment on your phone. So right after the completion of the payment, most of the apps have that green tick with that kind of success kind of visual and success kind of a sound and some vibratory feedback. So all of these things happen at the same time. So it's a multisensory input. So if I am hard of hearing, I can see the screen that yes, the payment has gone through. If it is if somebody is visually impaired, they can hear the audio feedback or the tactile feedback, and if somebody is deaf and blind, they can feel the audio feedback. Or if you're kind of distracted, even then you can just kind of rely on the vibrotactile feedback and move ahead. So let us now move to emerging output technologies. So emerging output technologies are driven again largely by artificial intelligence and are transforming accessibility by offering more personalized, intuitive and integrated ways for people with disabilities to interact with digital and physical environments. So this is a basic difference between a single model AI model, single modal AI model. So single type of data, single model, and in case of a multi AI model, it can take text, image, charts, audio, multiple kinds of inputs and generate multiple kinds of outputs. So, multimodal AI is able to enable multimodal interactions. So, input modalities can be biosignals for, say BCI, brain computer interactions, sensor based inputs. So, camera, all of those aspects count as sensors. Camera, mic, pressure sensor, temperature sensor, all of those. Visual signal again, which is a camera, then there is a sound, which is a mic. Tangible button pressing, which is like an intentional kind of an interaction. And the system is able to generate multimodal output, so graphic, sound, haptic, sensor based output as well. So, let us look at some examples in the emerging tech domain. So, we have classified them based on the kind of domain it falls into. So, first is artificial intelligence and machine learning based technologies. So, AI is the core engine behind many advancements, enabling more sophisticated and flexible assistive technology. So, for example, enhanced screen readers and TTS systems or text to speech systems. So, AI powered screen readers and TTS tools. So, TTS is read aloud tool, which I think again we spoke about in the AI session. So, even if you now open your system and you see your Microsoft Word, the latest version now has a read aloud button. If you go in the review, you can press that button and it will start reading the document. And similarly, in the main dashboard, there is also a mic logo which says dictate. Dictate is speech to text. So, it is an emerging input technology where it is speech can be converted directly into text. So, TTS is now able to provide more natural sound. Slowly it is becoming less robotic and better contextual understanding of the content, making the listening experiences less robotic, and more seamless for blind and low vision users and those with dyslexia. Real time captioning and transcription. So, automated speech recognition combined with AI algorithms are able to provide real time captioning for live conversations, and they are also able to do a real time translation. Right? So, one is listening, so automated speech recognition, listening and understanding and converting it into text of say one language, and then translating it in real time into text of a different language, and then again communicating it in an audio format using text to speech. So, this kind of a system is something which can totally be a game changer in terms of somebody is traveling from Japan to India and they do not know the language. They are able to speak into the system in their language, and the output is able to in real time understand, translate and communicate it to a local person in the regional language, which is say Hindi. So, it can be a very good tool for removing such limitations like language limitations. Then there can be models which are able to do image and scene recognition. So something like Microsoft Seeing AI, it is now able to do real time reading, so image analysis, obstacle detection, navigation, etc. Reading signs, describing a room, attending meetings, telling the person with visual impairment like who all are sitting on the table, which person is sitting on what side of you, and all of those aspects can be really helpful in the social inclusion part of. So the last point is content simplification. So generative AI models can simplify complex text into more readable formats and automatically generate descriptive alt text for images, aiding users with cognitive or learning disabilities. So descriptive alt text for images as well as videos can be generated, auto-generated, and the systems will be able to do that by themselves. And also especially for long format documents, AI models can simplify the complex text and kind of summarize it for your understanding and make it into more readable formats. So yeah, I mean, this is just one example of a potential AI driven output technology, which is live captioning. So there can be somebody who's delivering a speech. There can be somebody who's delivering a speech, and the video which is being played in the same stadium or the same auditorium is able to have live captioning generated in real time, and thus the gathering becomes accessible for persons with hearing impairment, because not all people may know sign language. One, maybe you would feel that why not sign language, but not all people would be knowing sign language because it's a different, altogether a new language, right? And also sign language is something which is again taught and learned by hard of hearing or people who are deaf and mute. But for example, people who are hard of hearing and are not mute, they don't really know most of the time sign language. And also elderly who have their auditory senses declining, they may also benefit from this technology. Now let's move on to the next category of emerging technologies, which is augmented reality and virtual reality based technologies. So AR and VR are moving beyond just arcade games, and now are able to provide practical real-time assistance by overlaying digital information onto the physical world. So navigation guidance is one important use case which can benefit from AR applications. AR applications can overlay virtual navigation paths onto a user's live camera view, providing real-time audio and haptic feedback to help visually impaired individuals navigate complex indoor and outdoor spaces. Although I would say that navigation of indoor spaces is still a very big open problem, and even outdoor spaces like parks, etc., because there are several aspects to navigation, and Of course, AR can be one of the aspects, can cover one of or two of the aspects. Several things like live camera can help in automated obstacle detection, can help in real-time audio and vibrotactile feedback, in wayfinding, all of those aspects. Contextual cues. So, AR glasses can provide real-time information about the surroundings, such as identifying objects or people, or translating sign language into text in real time for an improved communication. Such technologies can offer accessible virtual environments. So, for example, VR offers the potential for creating customizable virtual spaces, be it offices, be it museums, etc., allowing people with physical challenges to participate in activities that might be difficult in the physical world. And this is like one example where a virtual reality interface can allow people to interact with a museum kind of a setting, where they are able to walk around and interact with different aspects of. So it can be used for educational purposes, it can be used in tourism, etc. Now, the third category of emerging input technologies is under advanced human computer interfaces and wearables. So, innovations in how users interact with devices that are creating new output methods beyond traditional scenes is happening at a very fast pace. So, BCI, or brain computer interaction, is something that we have talked about. Still in early development, but BCI aims to allow individuals with severe motor impairments to control devices, robotic prosthesis, or even communicate using neural signals. Haptic feedback systems. So, haptic technology in smartwatches or wearables can use vibrations to convey information. Of course, the patterns, etc., there needs to be studied from a research perspective, such as directional cues for navigation or notification for users with hearing impairments. Just not relying only on audio cues or visual alerts. Voice activated technology. So, voice assistants like Siri, Alexa, Google have become mainstream input output tools, allowing hands free operation of smart houses and devices in an IoT setting, which is particularly beneficial for those with motor impairments or visual impairments. Even if you are able to walk, identifying the buttons and pointing the remote at the TV and pressing the right buttons, all of that also becomes very tricky. But say with Alexa or Google assistants, just from where you are sitting, you are able to control the television, or you are able to control your playlist, and I think that is something which is of great help. Then we come to tactile braille displays. Advancements in refreshable braille displays is as a haptic textual display as well as graphical display is making a lot of progress. It's now making digital content, including graphics and complex equations, accessible via tactile output. So, this is an example image of a tactile graphic display. So, maybe now studying something like biology, where you need to kind of go through more and more diagrams every day, that can be more accessible for persons or students. So, I think we saw the same image in the previous session also, and the point of it is that we are largely moving from a screen based, desktop based interface to a very interactive kind of an environment, which will be enabled by a lot of these technologies, where it would feel as if you're talking to robotic humanoid, and how the other person is able to perceive and semantically process and reply to all your queries and do the action items requested by you. So, to summarize, the future of accessibility lies in the seamless integration of these technologies into everyday consumer products. It is still a long time to go, but the core principles of accessibility by design should be followed, rather than thinking of accessibility as an afterthought. And some of the keywords which you can use for knowing more about this topic is emerging output technologies, AI based output devices, wearable output devices, adaptive output devices, and I think this kind of technologies will have a lot of potential in transforming digital accessibility and digital interaction. All the while, we have still a long way to go to talk about compliance and regulation about all of these dynamic input and output devices, because most of the content is generated in real time, and WCAG currently has not been designed with dynamic content in mind. It is largely designed for a static interface. So, guidelines and policies around the same also need to be thought of, and in order to know more about these gaps, you can refer to AI and accessibility lecture part 2, and where we have talked about all of these issues in detail. Thank you for joining us today, and we will see you in the next session.